All right, I'm starting our recording, and I'm going to share my screen with you guys, and we'll get some notes going. How about y'all get your notebooks out if you haven't got them out already, Nate? And all right, who have I not zapped? Georgie, come here. Yeah, nice mask, by the way. All right, we're good. Just getting our notes out, George. And you guys at home, we're starting a new section 1.3 in our text today, okay? 1.3. And it's all about fractions. And I told my freshmen, we hit this lesson up on Tuesday, so today you guys are getting it. And I told them, fractions get a bad rap. People are unnerved by fractions, okay? A little, I guess, premonition whenever you even hear your teacher use the word fraction. But today we're going to talk about how we can dispel some of those fears and anxieties dealing with fractions, okay? Because there could be nothing easier than simplifying, adding, subtracting, multiplying, and dividing fractions, okay? And you're going to get a chance to practice a lot of that with me this year, not just dealing with nice, easy fractions, but actually some hard, kick you upside the head algebraic fractions, okay? You'll have fractions where there's polynomials on the top and the bottom. You'll have fraction on fraction action where you've got like what's called a complex fraction where there's 3 or 4 fractions operating inside of one big giant fraction. And you're going to become proficient at all of that. Okay, but it's going to take some hard work and some patience and learning a few basic tenets. The first basic tenet I've got on the screen actually in blue there, and that's how we simplify fractions. And in your notes, you can jot down that we simplify fractions by canceling out a common factor from the top and the bottom. This is something you guys have been doing since probably 4th or 5th grade, right? This is where your teacher gave you 3 over 6, and then she expected you to simplify it down to 1 over 2, let's say, all right? So the reason behind why we can do this, the reason behind why we're able to cancel out, this common factor that we probably take for granted, it's operating in the background, is over here in red on the side. You see, we've got the commutative property of multiplication that says I can rearrange the order of my factors since I'm multiplying. All right, and multiplication and division taking place, with equal priority from left to right, as we studied in the previous lesson about order of operations. I can split this fraction up over here, and I can say, you know what? Let's deal with A over B, and let's deal with C over C. All right, so I don't have to multiply A times C. I don't have to multiply B times C. I could actually split this fraction up whichever way I like. And if I split it up as C over C, that's obviously equal to 1. And the commutative property now has given way to the identity property of multiplication, where we multiply by 1, and that's the same thing. So it winds up just being A over B. The long and short of it, as I showed you over here in blue, is that we can just scratch out common factors. We can cancel those bad boys out, okay? So you got your first example. Tiago, you with us? I'm going to ask you a question, Bubba. We got negative 315 over 700. Okay, Tiago, you in the house? I don't see you, brother.
Yes, sir. Yes, sir.
Okay, very good. I just see background. Tiago, what goes into 315 and 700 that you spot, right? Just easy. It doesn't have to be anything super fancy. What do you notice goes into both of those? A common factor, if you will.
They can both be divided by 5.
Yeah, very good. Okay, so we see that, and then we divide that out. So like if I were to rewrite this one, okay, I got my negative sign, and let's see, dividing it by 5 looks like 63 on the top, and dividing that one by 5, I think it's 140, if I'm doing that correctly in my head, because 5 times 40 is 200, 5 times 100 is 500, 200 and 500 makes 700. There we go. Now again, the sort of the behind the scenes look at what's going on there is that we said, okay, 315 is the same thing as 63 times 5, as Tiago said, and 700 is the same thing as 140 times 5. And we're choosing to what? Cancel those 5s out. And that's how we got up here to this fraction. Okay? Joey, what's something else that goes into the top and the bottom of that fraction? Spot anything else? No? Okay. 63 is an interesting number. It's got a couple of, actually it's got 3 factors. We could split it up if we mentally thought about, prime factorization. Okay, George, could you mentally give the prime factorization of 63? And it doesn't even have to be prime factorization. Tell me two factors of 63. Two numbers that go into 63. 9 and 7, good. And therefore, if we wanted to take prime factorization a step further, 9 could be split up as 3 squared. So 3 squared times 7 is my prime factorization. Now, 140 might be a little bit tougher, but if I start by dividing by 2, automatically right now I see it's divisible by 70, and then I'll go back to Joey and ask Joey, now that we've kind of played around with the factors, what do you notice that goes into both those? 7 indeed does go into both of those. So now we can split it up and we can say, okay, well, 7 goes in negative 9 times and 7 goes in 20 times, and there's my simplified fraction, right? We simplify fractions by canceling out common what? Common factors, okay? And again, the behind the scenes look at what we just did was we said negative 63 is negative 9 times 7, and 140 is 20 times 7. And we cancel those bad boys out, and that's how we got our answer. You don't have to show the steps of, behind the scenes of what's going on. You just need to understand that's what's going on. You need to have that in your mind as far as how we cancel those out. You guys have any questions on that first example? That's something comfortable.
I have a question.
Yeah, go ahead.
Does it matter like where you put the negative sign? Like, because on the first, like at the start, it was like on the side, and then you put it like by the 9.
Great question, Lewis. The answer to your question is no, it does not matter. Mathematically speaking, you would be correct if you put it out front, if you put it up top, if you put it down at the bottom. However, conventionally, we see it most often go with the numerator. And so you wouldn't, for instance, catch me writing it up as 9 over negative 20. You just won't see me do that. Okay, even though those are the same numerical answers, right? The negative sign, by convention. What does convention mean? That just means it's a common way that we do things. Okay, so conventionally we put the negative sign up top, and that's what you'll see me do most often. Okay, you ever hear anybody say, "Oh, that was unconventional"? Well, that just means that they're doing it in a way that most folks don't do it that way. Okay, so like if you're playing baseball and you got a guy that's a submariner, he's got an unconventional delivery. A submariner means he throws it down low underneath as opposed to throwing over the top. And so that's what we mean by convention, right? Now, if you look, good question, Lewis. Anybody else before we look at example 2? All right, let's look at example 2 here. If we're multiplying fractions, okay, it's very simple. I'm gonna give you a little catchphrase that I use, okay? A little catchphrase. Reed, here's your catchphrase. You multiply the top with the top and the bottom with the bottom. Okay, Nate, did you get that written down? I spoke it quickly. Let's write it down. The top with the top and the bottom with the bottom. Now you look at the second one, what's in parentheses right here, and Will Edwards, what is the problem with what I just said regarding that second factor here? I said multiply the top with the top and the bottom with the bottom. Look right here and you tell me. Top with top, bottom with bottom. That don't make no sense. Why not? Yeah, there ain't no bottom over here. Okay? So what? Big fat hairy deal. I care not, because Mr. Grove Thompson is going to tell me what is an implied or what is an understood denominator of negative 20x. 1. All right, as Three Dog Night would say, it is the what number? 1 is the... Y'all never heard that song?
One is the loneliest number.
Yes, that's what I'm talking about. How many of y'all have heard that song before? I know somebody in here has to. Oh my goodness gracious. Paul, you and I are operating on the same wavelength, brother. These guys, I don't know what's wrong with them. It is the loneliest number. But it's also an understood or an implied denominator here, okay? So now, did you see how I transformed it? I wrote it as a fraction. So now I can do my top with the top and bottom with the bottom. And we can go ahead and multiply, right? Right?
Yeah.
Wrong! Don't multiply yet. You fell right into that one. Okay, Nate's just finally waking up. That boy, Nate. We don't want to go ahead and multiply. Yeah, I know I said top with the top and the bottom with the bottom. But let me ask you a question. Has anybody moved recently? Anybody moved within the last, year or so? Okay, well, actually 3 or 4 of you guys. Okay. Like, would it make sense if we were moving, let's say I said, all right, George, I want you to go up to your room and get a sock and bring it down and put it in the moving van. And then go upstairs and you get a belt and put it in the moving van. And go upstairs and, oh, there's another sock. Let's put it in the moving van. And go upstairs, oh, get that shoe and put it in the moving van. No, that would not make sense at all. Could you eventually move like that? Sure you could. But what would make much more sense would be for George to do what? What do y'all think?
Bring everything
Yeah.
at the same time.
Yeah, pack it up, baby. Pack it up, pack it in. Let me begin. Jump around. You know, if we try to operate first, we're making more work for ourselves. But if we simplify first, this is what I would write down. If we simplify first before we operate, life is good. If we simplify before we operate. In other words, if I cancel common factors, if I cancel common factors first before I multiply, then I've got less work to do at the end. Okay? Let me show you what I'm talking about here. I'm going to do it two ways. I'll do it in green, where we multiply first. Okay? I don't recommend doing this at all. Okay? So 240x over 5. And then we simplify and we think, oh, okay, 240 divided by 5. Well, I know 5 goes into 48 times. 5 goes into 200, 40 times, so it looks like 48. All right, so 48x. And not that that was super strenuous mental math, right? But I was sitting there having to think, having to do a division. Heck, maybe even if the numbers were bigger or if I wasn't as proficient at mental division, maybe I'd actually have to lay out a long division problem and figure that out, okay? But check this. In orange, watch what happens. I can cancel out the 5 with the 20 much easier, okay? And I can say negative 12. Whoops, nudged it with my finger. I can say negative 12 and negative 4x and get my positive 48x. And I didn't have to do as strenuous of a mental, arithmetic. So in orange, I did what? I simplified first. We packed our bag before we moved it downstairs into the moving van. Okay? Now, is it legit to do it the green way? Sure it is. You get the right answer if you're on your toes. But it's more work. And you want to work smarter, not harder. You want to work smarter, not harder. Okay? So when we multiply fractions, it's top with top, bottom with bottom. What about when we divide fractions? Look at example 3 here. Now, I know one of you guys is a fried chicken fan. Y'all have been taught this. I had a 9th grader yesterday. Or not yesterday, excuse me, on Tuesday. He started talking about deadgum Kentucky Fried Chicken. Y'all know where I'm going with this?
No.
It must be an 8th grade teacher thing. I thought it was maybe like a 6th or 7th grade teacher thing. But keep, flip, change, KFC. Nobody's ever showed you that? Somebody ever told you, silly fraction, don't be shy, flip yourself and multiply? Y'all don't know that either? Okay. By the way, you guys at home, I'm not seeing any faces other than Lewis and Joe and Paul. What's up with y'all? Y'all all got busted cameras or something? Jake Oxley, your camera busted, boy?
I can see Jake.
My camera's on.
Yeah, I can see him.
You can see him. Oh, that's not fair. Why can't I see Jake? Can't see any of you guys. Oh
I
well.
can't see either.
Who knows, man? Who knows? Maybe it's like a schoolmate type thing. Because don't you and Lewis both go to school together?
Yes, sir.
I wonder if y'all have similar devices such that you guys can see each other. Maybe it's like a cool kids club or something. I don't know. Oh well. This notion of dividing, I want you to write something down. Actually, I'll type it in for you guys just so you can get it precisely. Division is defined as multiplying by the, and then it's an R word. What R word is it, Jack?
Reciprocal.
Say it again, Jack. Not remainder. Somebody online, Tiago, or who was it that said it?
Reciprocal.
Reciprocal. Okay, good. That's the word we're looking for. Reciprocal. I can't spell or talk to girls, but let's see if we can get this one taken care of. All right. That joke doesn't work as well anymore now that I'm married and I have kids. People, I think I said that at church one time when I was teaching Sunday school, and the adults in the room just looked at me like, he's kind of weird. Oh, well, it worked better when I was single and right out of college. But anywho, I was a mathematician, see, and so I always told that joke. I'm a mathematician. I can do math, but I can't spell or talk to girls. And then they would giggle and they'd say, "Oh, Coach Morgan, you're so funny." Gone are those days, I guess. I'm stuck with stupid tardy sauce jokes. That's all right. Let's see here. Division is defined by multiplying by the reciprocal. Somebody can tell me what the heck reciprocal means? I bet Jack can tell me. Candiata, what do you think reciprocal is? That's a vocab word right there, isn't it? Yeah, take a guess. It's okay if you don't know. Yeah, very good, very good. If you didn't hear him, he said it means to flip. Okay, so like the reciprocal of 3/4 would be 4/3, wouldn't it? The reciprocal of 1/2 would be 2. The reciprocal of -7/3 would be -3/7. Okay, so the idea of reciprocal is just whoop, flip the fraction. Don't change the sign, just whoop, flip the fraction. So this division problem, look at example 3. This division problem, we could rewrite it. I need a little more room here for just a sec. There we go. All right, so this division problem, we could rewrite it as what? -7/18. That's where that keep notion comes into play, where your teacher will say, oh, keep, flip, change. So we keep the first fraction. We flip the second fraction, right? So that's that reciprocal. So 27/14, and it's negative, so there's my negative. And then we change the operator to multiplication. Please catch those 3 things. You keep the first fraction just as it is. You flip the second one because that's reciprocal, right? And then you change it to multiplication. So if we remember that dividing is the same thing as multiplying by the reciprocal, then boom, we've got ourselves a problem just like example 2 now. And what's the first thing that I should do in a problem like, bless you, example 2? Should I go ahead and multiply -7 times 27?
No.
Oh, no. Let's try to cancel some common factors out. All right, let's try to cancel some common factors out. Who sees a common factor that they could cancel out there? Go, Alex. 7 and 14. All right, so that's going to leave me with, I'll just go ahead and cancel out this -2. It's kind of bugging me there, if y'all don't mind. 7 goes into itself once, goes into 14 twice. And then somebody at home holler at me if there's a common factor you want to cancel out that still remains.
27 and 18.
What about 27 and 18?
9. They both can divide by 9.
Each of those can divide by 9. So if I take out a 9, I'm left with 2. If I take out a 9, I'm left with 3. Now we've done our simplifying. Let's go ahead and multiply the top with the top and the bottom with the bottom. 1 times 3 is 3. 2 times 2 is 4. And all of a sudden, I got 3/4 for my answer. Okay? You guys done? Oh, go ahead. Question, Lewis.
So why did you cross out the negative signs? Do they not matter or something?
Oh, they do matter. I just canceled. I took that one upon myself to cancel out. What's negative times negative? A positive, right? A negative times a negative is a positive. So I went ahead and canceled those out. Now, let me adjust this problem just for a moment, okay? So, like per Lewis's question, suppose that the original problem only had the one negative there. What would I have to do? I would have to consider the negative that's still with that first numerator, and therefore when I multiply top with top, I get -1 times 3, and that would make it -3/4, right? So it goes back to that notion of if I have a pair of negatives that cancel out, if I've got an odd man left over, then he stays in and the problem remains negative. All right, good question, Lewis. You know what I'm noticing? This is so weird. I'm noticing all of my cameras are not working. Now I'm gonna do something real quick. Hold on a second. Let's just minimize this. See if we can bring this back up. No, boy, that's strange. Y'all are all frozen. Like Paul, you haven't moved in like 20 minutes. That's so weird, dude.
What?
I know, man. And Lewis and Joe, y'all are all froze. I'm just now noticing it. That's why I was hollering at Tiago a minute ago, because I still can't see him. But that's all right. Here, I'll show you what I'm talking about. See if this works. See what I'm talking about? Look at that. Y'all haven't moved. Y'all been frozen in time. It's the Twilight Zone. Y'all know what the Twilight Zone is?
Yep.
Heck, y'all didn't even know what was I getting fired up about earlier that y'all didn't know?
1's the loneliest number.
1 is the loneliest number. If you didn't know 3 Dog Night, you're definitely not going to know daggum Twilight Zone. All right, let's look at example 4. Twilight Zone used to be a show, and I think they actually probably did a reboot more recently. Oops, I didn't take everything with me. Where like something's, what is that 7/12's not moving? Where there's a will, there's a way. Let's do it this way. Something strange would happen. It was just like a story. Like they would tell the story about this man that he got off a bus in a strange town, and nobody could see him. It's as though he wasn't even there. You're about to enter the Twilight Zone, and they play this music, and then you'd watch the story unfold, and it would turn out that maybe like the man was dead, and he was his ghost walking around, and he didn't know it until the end. Anyway, fun little show called the Twilight Zone. You can go home and check that out, or maybe ask your grandparents if they ever watched it. All right, I digress. What in the world do we have here? We got ourselves, I mentioned this earlier, this is a little fraction on fraction action, right? We got a fraction on top of another fraction. So what should I do? What do you think, Jack? Okay, now you use the word solve. We can only solve equations, right? Like to solve an equation means to find any and all the numbers that when I plug them in for the variables, it makes a true statement. There's no equal sign here. This is no equation, so I can't solve an equation here. I can simplify an expression. So my job here would be to simplify this expression. How could I go about doing that? That's a better question, right? What do you think, George? Reducing, okay. How do I reduce this fraction? It's a weird fraction, isn't it? Like when I say pick a common factor on the top and on the bottom, what top am I talking about? What bottom am I talking about? It's weird. Okay, don't miss the forest for the trees, fellas. Don't miss the forest for the trees. What is this problem? Like, what is it in its essence?
It's a division problem.
It is. It's a division problem. That's very good, Oxley. And what did we just get through saying that division is defined as?
Multiplying a reciprocal.
Multiplying by reciprocal. So what we're going to do is we're going to keep, flip, and change. Okay? We're going to keep the first fraction, leave it alone, x over 2. We're going to flip the second fraction, making it 6 over xy, and then we're going to change the operator, multiplication. Because division can be expressed in more ways than just the little dash with the dot on the top and the bottom. Division can be expressed as a big old fraction. In fact, that's what a fraction is. It's a division of the numerator divided by the denominator, or the dividend divided by the divisor, to use some other terms. But now that I've expressed this as a multiplication problem, everybody and their brother ought to be able to simplify this out. Go ahead and do that for me. Go ahead and simplify this out. Okay. Cancel some common factors on the top and on the bottom. We'll give it another 15 seconds. I got tagged by that mosquito and I'm itching now. I like leaving my window open to whoosh out all the potential germs. But at the same time, I'm welcoming in all these critters. Oh, well. Will Edwards, you had wanted to take a shot at this, I believe. What did you cancel out? All right, so a 2 on the bottom cancels out. There he is again, trying to get me. 2 goes into itself once. 2 goes into 6 thrice. Okay, let me throw it over to Joe Edwards. And Joe, what else got to cancel?
You can cancel out the x and the x and xy.
Who's daggum yawning on this call? How dare you yawn? Very good, Joe, by the way. Cancel out an x on the top and on the bottom. Yawning. If anybody should be yawning, it should be me. Stayed up late last night. You know what I was doing late last night? I was watching TV. I got hooked. I watched about 5 episodes of Seinfeld. My wife fell asleep after the first or second one. I stayed in there. The best episode I saw last night was called The Junior Mint. Okay? Jerry and Kramer are up in like the gallery and they're watching an operation being done, and Kramer is comically eating Junior Mints up there, and he tries to hand Jerry one, and Jerry's like, "No, I don't want it," and he bats it away, and the Junior Mint goes flying, and then bloop, lands right down in the open, chest cavity of the guy, and the doctors didn't see it, so they sewed him up, and he started doing bad. And they thought they were going to lose him, and then all of a sudden he made a miraculous recovery, and the doctor was like, "I don't know what it was, but something staved off that infection." And I don't want to discount the medical evidence, but I think it was something from above. And the irony is that the Junior Mint came from above in the gallery. Really funny episode called Junior Mint. So y'all should check it out if you get a chance. Anywho, yeah, we got 3 over y. Now this was an easy problem once we figured out at the very beginning what to do, right? That's the hard deadgum thing about algebra. You guys are going to find that out this year. You're like, "Coach Moore, I can do all these problems as long as I know what to do." But you don't tell me what to do at the beginning of it. You didn't tell me this was a KFC problem at the beginning. It looked just like something completely different. All right? So here's the deal, y'all. I'm going to give you tools this year. I'm going to teach you how to use them. And you're going to put them in your tool bag or your tool belt or your toolbox or whatever you got them in. Okay? And then you're going to get out there and you're going to have a problem to face, and you're going to look at that bag of tools and you're going to be like, "Man, I got 100 tools in here. Which one should I pull out and use on this job?" Okay? The way that you learn to decipher and discern which tool goes in the appropriate spot here is by practice. Okay? The more you guys practice, they say experience is the best teacher, right? The more you guys experience, the better. Okay? I'm going to call it at example 4 today because we're about to get into adding and subtracting, and that can be waited. We can wait on that until tomorrow. I do believe, correct me if I'm wrong, that you guys worked a little homework for me over the last couple of days. Is this accurate? Yes, no?
Yes, sir.
It looked like this. All right. With the last 3 or 4 minutes in class, does anybody have any questions they want to look at? Anybody want to go over any of these? Now is your time to ask and for me to kind of help you check to make sure you were on the right path. And of course, Bob was helpful too, I hope. Anybody got any questions over this?
I did not do the homework because I couldn't find the pages with the answers that we were supposed to do, and that's why I was trying to get on Microsoft Teams.
Okay, so that's what your email was about. Well, real quick, let me remind you guys, this textbook, Paul, do you have this downloaded? Do you have this textbook?
Yeah, I have it downloaded.
Okay, so like this textbook operates just like a normal book where there's like a table of contents. And so this section 1.2, if you just scroll down to the end of that section, that's where those problems will be. And so like the numbers that I gave you guys, you would just jot those down in like your agenda or your assignments folder. Like say, okay, 60 through 126 multiples of 3. And then like as you're accessing, you don't have to go through Teams or anything. Actually, what I typically like to do. Oh, no, that's if I have the PDF open. Okay, never mind. I was going to say if I'm operating out of the PDF, I just go to 1.3 and then just scroll up a little bit. But this one actually has it sectioned off. So go to 1.2 if you're looking at it through the web. Don't come in yet, Nick. And just scroll down to the bottom, and then eventually you'll get to these problems like right there. And you can either do it via the web or you can do it like with printed, like printed out from the PDF. Paul, does that make more sense?
Yeah. But like what happened for me was I forgot the pages of the homework and I didn't write it down.
Well, you'll live and learn. You'll write it down. So did you catch what numbers those were? Did you write it down today? 60 through 126. It'll be a little extra practice for you. Get that done tonight. Jack, you had a question as well. Speak up real loud. A couple of what? Okay, so 60 and 62, we're just comparing values, right? So this would be where you would use your less than or greater than or equal to symbol, all right? So like, for example, look at the opposite of the absolute value of -9. Let's just look at that first one right there, okay? Absolute value of -9 is 9, and yet the opposite of that would be -9. And then over here, the absolute value of -9 is 9. So how would we compare that? We'd say -9 is less than +9. That's the kind of deal what we're doing there, okay? The absolute value of -8 is 8. And again, -8 is less than 8. Absolute value of -1 is 1. 1 is greater than -1. And then what's the opposite of -14? It'd be +14. And then over here, the absolute value of -14 is 14. And the opposite of that, we'd say, oh, 14 is greater than -14. So those kinds of comparisons are what we're doing. And they're just checking to see if you understand the notion of absolute value with that type of thing. So you're making those kinds of comparisons. Does that make sense, Jack? Okay, awesome. Anybody else before you guys head on out? Well, I will cut it off here, fellas. I hope that you have a wonderful day and look forward to seeing you guys again tomorrow. Word to the wise, if you enjoy streaming our football games, we're actually playing tonight. So if you guys want to stream, tonight's the first live home football game for Christian Brothers. So it'll be kickoff at 7 o'clock, and I think you guys can stream from our website. So just a little pitch there for you. Live Jesus in our hearts.
Forever.
All right. Thank you so much, fellas.
Thank you.